Assalamu alaikum. My name is Abrar Ali Qasim Al-Kinani. I'm MSc student. My supervisors Hilal Abbood Al-Libawy. My research title Electrical Machine Load Estimation based on Thermal Imaging and Deep Learning Approach. Outline 1. Introduction to related work. 3. Problem statement for future work and open challenge. 5. Traditional method of measuring instrument. 6. Comparison of classifiers for fault detection. 7. Heat generation and loss mechanism in electrical machine. 8. Result and 9. Conclusion. Introduction. Why do we need intelligent motor load estimation? Enable energy assessment and mechanical load estimation without physical contact, making it ideal for industrial and safety critical application. Thermal pattern correlate directly with the system workload. Different load produce distinct heat distributions, making thermal imaging and the effective diagnostic tool. Deep learning models like CNNs automatically extract features from thermal imaging, identifying load level with minimal human intervention. Over a contactless real-time solution for load monitoring, reducing downtime and enabling predictive maintenance, optimize performance in manufacturing, building management, and energy system by predicting load behavior and adjusting operations dynamically. While a prior study focused on fault detection, this approach emphasizes load estimation as a proactive tool for system efficiency and equipment longevity. This table summarizes a recent study for motor load fault estimation using thermal imaging and machine learning. A problem statement. Conventional motor load estimation method rely on physical sensor. However, in industrial environments, these sensors are often difficult to install and maintain. This leads to limitation in real-time monitoring and may increase the risk of undetected overload and energy inefficiencies. To address this issue, this research proposes a non-contact solution based on thermal imaging and convolutional neural network. The idea is to estimate motor load using surface temperature data instead of physical sensor. This approach aims to provide a safer, more scalable and cost-effective monitoring system. In other words, we can monitor motor load without direct contact, which is more practical for real-world application. Future work and open challenge focus on accurate energy and mechanical load prediction for DC motor using thermal data. Enable smart contactless assessment in DC motor application, no wiring or sensor installation. Utilize CNNs to detect load pattern in DC motor under varying operational conditions automatically. Support data-driven decision and reduce downtime through early load pattern recognition in DC motor. promote sustainable all-powered energy management across DC motor-driven system. Traditional method of measuring instrument. Traditional methods such as clamp meters, power analyzer, and torque sensor rely on direct electrical or mechanical measurements. While they provide accurate result, they require physical sensor, complex installation, and continuous maintenance. These limitations make them less practical in industrial environments. Therefore, a non-contactless intelligent solution is needed, which is the main motivation behind this research. Input rated current analysis determines load by comparing actual current to rated current value. Comparison of a classifier for fault detection. CVM support vector machine used as a classification layer after inception V3, replacing the original layer with SVM, improve performance, achieve 100% accuracy, precision, recall, and F1 score. CNN convolutional neural network used to classify bearing fault in single phase induction motor, simple yet highly effective architecture, achieve 100% classification accuracy. KNN nearest neighbors classified motor bearing fault based on selected thermal feature, achieve 98.29% accuracy, known for simplicity and effectiveness without linear multi-class data. Heat generation and loss mechanism in electrical machine. Heat generated in the machine. Heat is generated in the component due to current passing through the resistance calculated by this equation. Heat loss by convection. Heat is lost from the surface to the air by convection, calculated by this equation. Result. The model achieved very high classification accuracy, indicating its effectiveness in recognizing different load level. The training and validation curve show stable learning behavior and good convergence without overfitting. The confusion matrix demonstrates that most samples are correctly classified across all load classes. The pair classes accuracy confirms balance performance for all categories. Finally, the ROC and precision recall curve show excellent result with AUC values close to 1. This table show the result of experiment of DC motor. Conclusion. Most past studies focus on fault detection, not on actual load estimation in DC motor. Limitation: they ignore the real-time load behaviors. Some methods still depend on bulky sensor. Problem: these intrusive and hard to install. Deep learning and thermal imaging offer a smart non-contact sensorless approach. Strength: use only heat pattern to infer machine load. This research highlight a new direction: estimation load without physical sensor. Use CNNS to read thermal imaging instead. This picture shows the experiment for DC motor. Thank you for listening.